Chapter 4. Part 4. The form of the conditioned response. In laboratory studies of classical conditioning research, and in many of the examples we've discussed so far, the conditioned response and unconditioned response are very similar responses. That isn't always the case. This video covers some ideas about what determines the form of the conditioned response. For many drugs of abuse and other substances, the effectiveness of the drug decreases with repeated use. This is drug tolerance. In practice, this often means drug users continually increase the dose in order to produce the same effect. If you're a coffee drinker, you've experienced this yourself if you find that you're drinking more coffee or stronger coffee now than when you first started drinking coffee. Shepard-Siegel proposed that compensatory conditioned responses are part of the reason drug tolerance develops. A compensatory conditioned response is a conditioned response that counteracts an unconditioned response and helps to maintain homeostasis. For example, if your shower at home is always too hot, one unconditioned response might be an increase in your body temperature when the too hot water touches you. You might develop a conditioned response to contextual stimuli, the sound of turning on the tap or even just being in the bathroom itself. That conditioned response would be a compensatory conditioned response if it lowers your body temperature slightly, for example, by changing your breathing rate or your blood pressure, in anticipation of the unconditioned stimulus, the hot water, and its effects on your internal temperature. The basis for Siegel's suggestion that compensatory conditioned responses are involved in drug tolerance was his experiments with rats and morphine. Morphine is an analgesic. It makes the subject less sensitive to pain. Now, if the subject is in pain and wants that pain to stop, that's the whole point. But in general, sensitivity to pain is adaptive. The sensation of pain is what tells you to move your hand from a hot stove so that it doesn't burn, for example. Siegel gave rats in his experimental group injections of morphine and rats in his control group injections of saline, and then measured their pain sensitivity over 4 trials. Control group rats' responses did not change over the 4 trials. Initially, the experimental group rats that got the morphine injections showed reduced sensitivity to pain. Compared to the control group, they did not remove their paws from a hot, unconditioned stimulus until more time had passed. This is evidence of the analgesic effects of the morphine. So the unconditioned stimulus is the morphine, and the unconditioned response is analgesia. With each subsequent trial, the experimental group rats' responses became more like those of the control group until, by the 4th trial, there was no difference. Siegel interpreted this as compensatory hyperalgesia in response to drug-related cues, that is, the stimuli in the room where the injections occurred. To test that hypothesis, he repeated the experiment, but this time, on the 4th trial, he changed the location where the injections occurred. Without the conditioned stimuli from the previous trials, rats showed a strong analgesic response to the morphine, similar to the first trial. Something analogous can occur with drug overdoses. Siegel and colleagues identified multiple instances of heroin overdoses where the dose the person took was similar to one that they had previously tolerated. In those cases, the context was new. Different people, places, or other cues than their normal drug-taking circumstances. Without the compensatory conditioned response to the usual conditioned stimuli, the reaction to the usual dose was much stronger. The good news is that this information can be incorporated into treatment programs. Cue exposure treatment programs for addictions involve removal of the US, for example, the drug, and extinction of drug-related cues, the conditioned stimuli, that may elicit compensatory responses. In general, the more effective the extinction, the lower the likelihood of relapse. When we discussed Solomon and Corbett's opponent process theory in Chapter 2, both the A process and the B process were described as unconditioned responses. There was no conditioning involved. Jonathan Shull suggested that instead the B process is actually a conditioned response. According to this modified theory, drug-related cues elicit a compensatory response that's established through classical conditioning. When the conditioned stimulus is combined with the unconditioned stimulus, the drug, the net effect is tolerance. According to Shull's version of the theory, withdrawal symptoms occur when the conditioned stimuli are presented without the unconditioned stimulus. The CSs elicit the compensatory response, but there's nothing to compensate for, so you get withdrawal. Alan Wagner borrowed some of this terminology to propose a sometimes opponent process theory. Sometimes opponent process theory specifies that a conditioned response will mimic the unconditioned response if the unconditioned response is monophasic, and compensate for the unconditioned response if it is biphasic, meaning there's a rebound effect. Sometimes, as in the examples in the textbook, it's easy to tell whether the unconditioned response will be biphasic or not. Eye blinks are clearly monophasic, there's no rebound effect. Changes in heart rate are biphasic because the body will always work to return to the resting heart rate. Can you think of other examples of biphasic unconditioned responses? What would the compensatory conditioned response be? Can you think of any examples where you're not sure whether the unconditioned response is monophasic or biphasic? Let's plan to discuss them in class.